So, good day everyone. I am Christine Era Renada, and our topic for today is all about lesson 3 simple equation involving more operations. But before that, let's have our objective. So, to use different strategies to solve for the unknown in simple equations involving more operations on the whole numbers and fractions. But have questions to be answered. What is an equation and how do you find an unknown given an equation with one operation? So, an equation is a mathematical statement asserting that two expressions are equal, and it contains an equal signs with an expression on each side. So, the expression can involve numbers or variables and operations like addition, subtraction, multiplication, and division. So the goal here is to often find the value or values of the unknown variables or variables that makes the equation. So now let's proceed to solving simple equation using only addition. So the strategy here is to isolate the variable or the unknown variable by adding the same value to both sides of the equation until the variable is by itself. Imagine a scale to keep it balanced. Whatever you do to one side, you must do to the other. So let's have an example. A whole number. So x minus 5 equals to 12. So think of it like this. Something minus 5 equals to 12. To find something, or the x, we need to add the 5 back. So we add 5 to both sides, to the left and to the right, of the equal sign to keep it balanced. So what we have here is x minus 5 plus 5 equals 12 plus 5. And now we need to cut off the 5, both 5 between the equal sign. So we have the remaining 12 plus 5. And 12 plus 5 is equals to, yes, 17. So now our variable of x is 17. Now, if you understand the first example of a whole numbers in addition, simple equation, let's proceed to example 2, which is the fraction. So we have here x minus 2/3 equals to 1/6. So again, we're missing a part. So to find x, we add 2/3 to both sides. But we'll need the same pieces to add fractions. So we change 2/3 to 4/6. So what we have here now is x minus 2/3 plus 2/3 equals 1/6 plus 4/6. So again, we have 4/6 because we need the same size pieces to add fractions. So we change the 2/3 to 4/6. And now we have to add the 1/6 plus 4/6. So 1 plus 4 is equals to 5 and copy the denominator. So that's it for solving simple equations using only addition. And now that you understand solving simple equations using only addition, let's proceed to solving simple equations using only subtraction. So here, the strategy is similar, yes, but we use subtraction to isolate the variable. Here, an example here is a whole number. So x plus 7 equals to 15. So something plus 7 equals to 15. So to find something, we take away the 7 from both sides. So here, we have here x plus 7 minus 7 equals to 15 minus 7. And 7 minus 7 is automatically 0. So we have the remaining 15 minus 7. So 15 minus 7 is equals to 8. So therefore, our something or the x variable is 8. Another example in fractions of solving equations using subtraction, we have here x plus 1/4 equals 5/8. So again, we need to take away 1/4 from both sides. So to do this easily, we change 1/4 into 2/8 because 1/4 plus 1/4, like we multiply it by 2. So we have the same size pieces. So again, we change 1/4 into 2/8, so we have the same size pieces. So what we have here is x plus 1/4 minus 1/4 equals 5/8 minus 2/8. So 2/8, 1/4 and 1/4, we cancel out that, and the remaining is 5/8 and 2/8. So 5/8 minus 2/8 is equals to, again, 5 minus 2 is equals to 3. And we have to copy the denominator. So we have x is equals to 3/8. So remember that always do the same things to both sides to keep the equation balanced, like seesaw. And if you're adding or subtracting fractions, make sure you use the same size pieces or the common denominators. So that's all.
So good day everyone, I am Mercedes. So I will be your teacher for today. So our topic for today is all about multiplications, division equations. So it's just what it sounds like we'll need to do in order to solve these equations. So now you may be able to solve some or all of these using mental math. But we're going to do through this using a process. Knowing and understanding this process will help solve equations that are more complex and or they want to able to solve using mental math. So at the top of this screen is a very important note. We need to isolate the variable get in by itself by using the inverse or opposite operation. And always remember balance. So let's exactly what that means. As we go to my 4 examples, and we'll jump right into number 1, where we have 6 times equals 24. So we need to isolate that variable of x now whenever we have a number. Right next to our variable to the 6, right next to the x. That means to multiply these problems means 6 times x equals 24. So for multiplying by 6, the inverse or opposite operation would be to divided by 6. So let's provide the left side by 6. So in order to isolate the x, because these 6 are going to cancel out. Okay, cancel na nato ni. So to speak 6 divided by 6, there give us 1x. So x na ni siya dire. Equals. So which we can just write x. And there we have to isolate it. So now remember, we have to keep everything balanced. So whatever we do to one side, we have to do to the others. So if we divided the left by 6, we have to divide it by the right by 6. So 24 divided by 6 is equal to 4. And we have our answer, x equals 4. Okay. Now we can always double check our answer by plugging it back into the original equations. So, checking. So, 6 times 4 equals 24. Okay, check siya, no? So that is true. So we have the correct answer. So now, let's move to number 2. Which log is a little different than number 1? Because we have the 72 on the left and the 9 times are on the right. So the variable is on the right, but we use the same exact process. So we need to isolate the r. Isolate the r. We're multiplying the r by the 9. So the opposite would be dividing by 9. Now, those 9s cancel out and give us 1 or r, which we can express by just writing r. And then by itself, so that r is isolated. Whatever we do, the one side, we have to do the others. So 72 divided by 9, 72 divided by 9 equals 8. So the answer is 8 equals r. So, and we can plug back into here. So, to see if this is true. So 72 equals 9 times 8 times 8. So, which is true? You can think of these equations like balancing. Balancing a scales, each side has to be exactly equal. So the left we have 72 and on the right we have 9 times 8, which is also 72. So these two sides are equal. So let's moving on to number 3. So we have v divided by 3 equals 5. So let's isolate the v. We are dividing it 3. So the opposite would be to multiply it by 3. So let's multiply the left by 3. So multiply 3. So on the right by 3. So these 3 cancel out. There are we isolated the v equals, okay. And 5 times 3 is equals, 5 times 3 equals 15. Okay. So we get to v equals 15 and we can plug back into make sure and we can connect because 15 divided by 3 equals 5. And lastly, we have number 4 where we have 4 equals a divided by 9. So we need to isolate the variable of a. So we are dividing it by 9. So the opposite would be to multiply that side by 9. So side by 9. And whatever we do, to one side we have to do, to the other side to multiply both side by 9. So this 9 cancel out. This 9 cancel out. So this left with the isolated a. Then 9 times 4 equals 36 equal a. So this is the correct answer. 36 equals a. And we can double check here. So 4 equals 36 divided by 9. Both sides are equal. So we have the correct answer. For the value of our variable a, so there you have it, there's how to solve. So this is multiplication division equation. So I hope that helped you. Thank you for watching.